We're at Great Esker Park in Weymouth, Massachusetts, and I'm Greg Mertz.
I'm Zach Mertz.
And we are from the New England Wildlife Center. And we're going to take a little walk around the property today, looking at the different features of Great Esker Park. It's a cool little park because it is, in fact, a glacial esker, and a very good example of a glacial esker. And we're standing at the bottom of the esker, and if you look up the hill, you're seeing there's quite a rise here. And an esker is the flow channel of water underneath the glacier as it melted. You know, these glaciers were, realized they could have been a mile thick, and as they reached the end of their expanse, they hit warm weather, and it caused them to melt. And as there was water running underneath the glacier, as things began to seep down and melt through. And as it melted through, it created a channel underneath the glacier, and it carried sediment with us, and so it sort of filled in the channel of water where it ran. And what we're looking at here is the side of the esker, and if we get up to the top of the hill, we're going to look, and we're actually going to be able to see that the esker kind of, in a sinuous pattern, works its way along the coastline of the Weymouth Back River. So let's go up the hill.
All right, let's do it.
Okay.
Hey, so we're at the top of the hill now. As you can see behind us, we have marshland, salt marsh over there. The other side, terrestrial woodland.
I would just like to point out, I just wouldn't mind doing that pan again, because I really want to point out that this is a steep hill to the right, and this is a very steep hill to the left. So we're standing right at the pinnacle of the esker. And the esker, if you look up the hill, goes around a bend. And if you look on 180 degrees and look down the path, you see that it goes around a bend and then around another bend. So this is a sinuous, snake-like hill that is the sediment that was left behind when the water melted off of the glacier.
Cool. So, Greg said we're standing at the top of this pyramid. What does that mean for the plants and animals that live here? What kind of habitat does that create?
Well, the kind of habitat, because this is made of fluvial material, because this is made of the sediments that were carried by an under-glacier river, it means that it's really just pebbles and stones, river stones, and it's a big pile of it. And so, because of that, it is very well drained. And by being very well drained, it makes it a fairly dry upland woodland. So the kinds of plants and animals we see around here, well, we have a black oak tree here, we have a white oak tree over here, and so it's an oakland woodland with some of the other things that fit into. Here's a black cherry, and it's a fairly exposed to the light. So it's a mixed woodland, but it's an oak woodland. So we're standing on the top of Great Esker, and it's an upland woodland area. And I mean, just point out a few of the plants, a couple of different kinds of trees, and these plants are going to dictate what kind of animals live here. Right behind me is a black cherry. Black cherries like very bright, open sunlight areas, and you can see it's kind of a diminutive black cherry, and that's because there are bigger trees around it that are beginning to shade it out, so it's not competing as well as it probably once did when this was little fewer number of plants around. Black cherries are pretty cool. They make cherries, which the black cherries are really preferred by all kinds of songbirds. Some squirrels, things like raccoons, chipmunks, things like that will eat the black cherry when it's ripe. The leaves themselves are very poisonous to eat, so you don't see a lot of animals eating black cherry. Okay. Beyond that, you see a gray birch. The gray birch is very easy to identify because it's pretty white colored, but the actual type of birch it is gray. And these are, again, fairly non-dominating kinds of trees in an environment like this. They get shaded out reasonably quickly. They do provide food for a type of insect called a leaf miner. And that's important because that's the building of the food web. Although it doesn't make a seed that any particular animal eats, except maybe a mouse or something might eat a little bit of the seed, the fact that it provides food for insects means there are a lot of songbirds that are able to live here because there's food coming from the insects that feed on this tree. And if we look down the trail, we're going to go off the esker now. We're going down the hill. We're going to see a black oak. Next to it, we're going to see a white oak. And we're going to continue down. This is another white oak tree. Here's a black cherry again. Has Virginia creeper climbing up. It's a vine. Cool thing about vines is that they take way less energy to grow. It takes a lot of energy to build a trunk. It takes a lot of energy to build the branches and the leaves. Whereas if you're a vine and you're leaning on something else, all the energy that would go into producing that trunk goes to helping the vine grow taller and higher and reach out into the sunlight where it gets its energy to make the sugar through photosynthesis. We come on down the trail a little bit farther. Tree at bloom. That's a dogwood, and that dogwood, again, sort of an ornamental style plant in the middle of the woodland. It's got lots of insects around those flowers, and again, those insects become the base. They're the base for the food chain that you're going to see in this woodland. So, what kind of animals live here? Well, certainly lots of songbirds. If we stop and listen, you hear them. We hear a number of different kinds of birds in the background, and it's because of the insects that are living here. It's because of the seeds that are being produced, and it's the foundation of this food chain is coming from the plants that are living here. Looks like in the park here, very recently, there was a fire. It didn't go very far, luckily, did not go very far, but you can see the burned carbon of the leaves and the bark and whatnot. Zach here has brought up a log, and if you look at it, you can see that it was a fairly hot fire. Not the kind of forest fires we think about when we think about out west, but a fire like this can do an awful lot of damage to the plants, the animals, and the whole food web, and to the habitat. Don't be confused. There are some forest fires that are important in maintaining the ecology or the health of a particular system. This is not one of them. This is probably more the result of carelessness or vandalism or something of that sort. And these kinds of occurrences do real damage. It'll be probably 2 months before we see any sprouts of anything alive again underneath.
We've made it to the bottom of the esker. We've probably dropped a good, I'd say 50 feet in elevation. You can see right off that steep bank. And what we found behind me, you can look out and see a little bit of marshland, and currently it's filled up with water. This is what's known as a vernal pool. They form in the spring and will last all summer until they eventually dry up this fall. These are really important habitats for amphibians, reptiles, and insects. As a testament to that, you can hear all of the birds and activity that's going on behind me. We just saw a red-winged blackbird. You can hear some crows, some warblers. And that is probably because of the amount of insects and food that is taking place and isn't available in this habitat right now. And as you said, this will probably begin to evaporate out this fall, but until then it will remain a very active and important habitat feature.
We're standing at the bottom of the esker, and we're looking away from the vernal pond, and we're looking out into the tidal marsh, which you can see behind us. That's part of the Weymouth Back River. That's an estuary. We're going to talk about that in a little bit. What I wanted to point out here was there's a lot of vines here, and this vine is called greenbrier, and it's a real briar. I mean, it has some nasty, wicked thorns on it that if you pull through it or walk through it, you're going to get cuts and rips and everything on your arms and legs. It is great protection. It's great protection from this plant being preyed on by things like deer. It's very tasty, it turns out, and it keeps things like deer and other grazers like cows and sheep and all that kind of stuff from eating it. And if you look at these little shoots, these are the brand new tiny little leaves that are pulling up out of the buds on the vine itself. You pull these up and look at them, and they're good to eat. Just like us eating a salad. And this is about the only time of year that you can eat it, because if you try to eat it in the summertime, it gets very tough, very hard to digest. But it's a great little plant to, if you like edible plants, try something.
So we are actually out on the flats themselves right now. We have the estuary to our backs. And what you can see here, see these long straight channels you have running through the estuary itself. These are actually probably man-made at one point.
They were man-made by the CCC camps. This is back in the time of the Great Depression. The government had a program where they put a lot of people to work as a way of providing a work incentive, but also a monetary reward so that they could support their families. And they had a lot of projects, and one of the projects they had was to try to reduce mosquito populations, because they were worried about things like malaria and eastern equine encephalitis, although they probably didn't know what that was, and just insect-borne diseases. And so they dug these ditches to drain the tidal marsh, to get rid of the habitat for the mosquitoes. What they didn't understand was that by creating these channels, there was no way to drain this salt flat, this marsh flat. It actually created the perfect habitat for mosquitoes.
And a lot of other things. These are actually some of the most productive habitats in the world. And the reason being is because although they are tidally influenced and do have some salt in them, they're not as salty as you would find in the ocean. And as a result, you get whole habitats and communities of freshwater organisms living side by side with saltwater organisms. So we're down at the bottom of the esker again. This time we are right in the middle of the estuary. As you can see, the water flowing behind me is flowing out of this reservoir to our left, and is it's making its way back out to sea eventually, which is that way. So as you might surmise, the tide is flowing out. This is a really important time for the animals and communities that live primarily within the salt marsh, because you can see the water level has risen a little bit. There's a lot of flow. Now is the perfect time for them to migrate out back into the bay, and that's going to be all the species that need to stay wet all the time, because this section over here will eventually start to dry out, and if you're an organism that likes water and needs water to breathe or something like that, you better get out of here before the tide is completely evaporated on you. I wanted to show you a little bit. As you can see, the water's not flowing in a straight line as you might think. You can see a lot of curvature in the topographical features. It keeps curving until it makes its way all the way out to the bay. And that sinuosity, or curviness, as they call it, is indicative of a healthy ecosystem. You always want to see these curves. That allows for the movement of sediment and nutrients around the entire system, and really creates a wholesome habitat for everything that lives here. Hey guys, we're down here on the estuary again. What I just picked up, you can see, is a blue mussel called Mytilus edulis in the Latin classification. As you can see, there's no one home in this one. This guy has died and probably since become food for somebody else. But these shells they leave behind are actually a really important part of the ecosystem. These shells are made almost entirely of pure carbon. In the form it's in right now, not bioavailable. Bioavailable means can be used by other animals and organisms in the ecosystem. But over time, as these shells start to break down and degrade, they will become more available and go back into the water column. They can be used to build shells, part of the carbon exchange, a really important driver of what makes this ecosystem work. Hey guys, I have in my hand a plant called bladderwrack. Very common to estuary and coastal ecosystems. Very interesting plant. So you can see it's called bladderwrack because it has these air bladders in it that serve to make the plant float when it's in water, and when it's out of the water, they hold and maintain a lot of moisture, so it allows the plant to withstand a long period without water, generally about 6 hours, which is the tidal interchange. But as you'll see, it's laying flat on the ground right there, and when the water column comes in, it'll pick up and begin to float. And by floating, it allows it to gain sunlight and good exposure to oxygen and everything that it needs to survive. Additionally, it makes great food for some of the animals that live here.
Well, thank you very much for coming on this tour of Great Esker Park with us. As you can see, we're back at New England Wildlife Center now. We hope that you'll have a chance to walk the trails in Great Esker Park. It is a great park for the city of Weymouth. And we'll see you again next time. Thank you.